Okay, chapter 3, day 1. We go back to chapter 3, the beginning of the book, because now we're going to start to look at the data, organize the data, and be able to make graphs and charts of the data that we gathered through surveys or through experiments. So, chapter 3, day 1, what we're going to focus on is how do we describe and display what's called categorical data. There's two types of data. Quantitative, those are quantities, numerical items, values that you can add up and take an average of. And there's categorical data. And categorical data is data that you can find percentages of. It's a count of like how many out of total. So for example, what percent of the people have a gray shirt on, or what percent are male or female, or what percent are 9th graders or 10th graders. It's just counting of how many out of total is categorical. It's not numerical. So we display categorical data using bar graphs, pie charts. We display them with two-way tables, and we also use segmented bar graphs. So a variety of different graphs and charts. So here's some data that I gathered on eye color and gender from a class that I had. So in my class, I had 21 total students, and the brown eyes, blue eyes, green eyes, and hazel was broken down into male and female. And you can see the totals. There were 8 males in the class, 13 females in the class. In the class, there were 9 kids with brown eyes, 3 kids with blue, 5 with green, and 4 with hazel. Total 21 kids. And if you add this way, you'll get 21. Or if you add in this direction, you'll also get 21 total kids. So that's our data that I gathered. So now I want to display it. So the first thing is called a marginal distribution. It is a distribution of the totals of one variable out of the total sample size. And it's important. It is out of the total sample size for marginal. When you have a paper, the margins are on the edges. With a chart, what's along the edges are the totals. So if you can help you remember, marginal is always the total of one of the variables out of the total sample size. So let's create the marginal distribution of eye color. So I don't care about gender. I always want to look at just right now eye color. So I go back to my eye colors. 9 out of 21 are brown. 3 out of 21 are blue. 5 out of 21 are green. 4 out of 21 are hazel. So 9 out of 21, 3 out of 21, 5 out of 21, 4 out of 20. Notice they're all out of the total sample size, and the top number is how many in each eye color category, because I just want the distribution of eye color. And those are my percentages. They should add up to 99, 100, or 101 due to rounding. If they don't, then you got to check some of your work. All right, so now I make a graphical display with a bar graph. And so what I have here is all of these percentages. It doesn't matter what order you put them in. Each color gets its own bar, separated by some form of a gap. It doesn't matter how big the gap is. Doesn't matter which one you list first. So blue was 14%, so blue I went up to 14%. Green, 24%, so I go up to 24%. Hazel was 19%, so I go up to 19%, and brown was 43%. And that is a marginal distribution of eye color. You just want to make sure you label percent, and then here we would label it eye color, because unless we give it a label, we really don't know what we're talking about. And that would be a complete marginal distribution, both numerically and graphically. I believe you did some of this when you did Algebra 1. Next, we're going to look at what's called a conditional distribution. It is the distribution of one variable, not out of the total sample size, but out of the other variable. Okay? So it's a distribution of one of the variables, maybe eye color, out of a gender. So questions that I might ask with conditional might be, what percent of the males have blue eyes? So in this case, of the males, it's out of only the males. So I go back to my chart. I look at only the males. So I look only here. I have 8 total males, and 1 out of 8 have blue eyes. Because I said among the males, I don't care about the rest of the chart. I look at only the males. 1 blue out of 8. And so this is a symbol for and. So blue and male divided by male. So 1 of them were blue and male out of the 8, which is about 12.5%. How about this? What percent of blue-eyed students are male? It sounds like the same, but now it's of or out of the blue-eyed students. So I go back to my chart and I look at the blue-eyed students. So now I only want to focus right here. That's all I want to focus on is only the blue-eyed students. And the males are the top group. So out of only the blue-eyed students, 1 out of 3 are male. So 1 out of 3. Again, blue eyes in male, but out of only the blue-eyed students now. So 1 out of 3. You don't have to use the symbols. You can just use the numbers if you want. And 1/3 is 33%. A graphical display of a conditional distribution is what's called a segmented bar graph. The marginal distribution is a bar graph. The conditional is segmented. It's a bar graph with segments. I know it sounds silly, but so let's try graph the conditional distribution of eye color, but among the genders. All right? So what we have to do is among or out of each gender, what is my distribution of eye color? So let's start with the males first of all. Okay? So if I focus on only the males, I go back to my chart. So among the genders or out of the genders. So I'm going to focus my attention right here out of the gender, each gender. So for the males, 3 are brown, 1 are blue, 1 is green, 3 are hazel out of 8. So 3, 1, 1, 3 out of 8. For the females, 6, 2, 4, 1 out of 13. Because it's each gender separately. So among the males, 1 was blue, 3 was brown, 3 hazel, 1 green out of 8. And the females, there were 13 females, 2 were blue, 6 were brown, 1 hazel, and 4 green, and these are the percentages that go with that. And so what you're going to make is a segmented bar graph. And it's a bar graph that extends to a full 100%. Okay? So what happens is, I'll just show you how we created the males here for a second. You start out with a bar that goes all the way up to 100 over and down. And you can label it male. Now, you go to your percentages. What do we know? We know that 12.5% are blue. So I make my first line approximately 12.5, and I label it blue. 37.5 are brown. Well, these will stack on top of each other, so a total of 49, 50. 49 plus another one, 50. So this mark goes at the 50% because it's stacked blue plus the brown add up to a total of 50%. Now 50% plus another 37.5, which is 87.5, is my hazel line. That's up in here somewhere. It's a rough estimate, but do your best. And there's my hazel group. My remainder is my green, and so that marked that green. And that's how you make a segmented bar graph. Same thing with the females. I started with just a complete 100%, and then I chopped it into 15 plus 60 plus 46 is 61. So that comes up to 61. 8 more, 69. 31 more brings me up to my 100. So that is a segmented bar graph, and this would be a label of gender. So that is conditional distributions. We use segmented bar graphs, and what the total is out of depends on which variable we're looking at. Marginal distributions, the total is always the total sample size, and the bar graphs we make are whatever each percentage is separately. And so that's the first part.